Hello, it's Brian from Roboticy again, and today we're going to go ahead and continue on with the big Arduino project, trying to make a Teddy Ruxpin driving a Batmobile with GPS navigation, and should have audio and all kinds of cool stuff. The last couple of videos I've shown at least one way to hook up a RC receiver to a Teensy Arduino. Which is now sitting on a Roboticy T3 motherboard. And what I'm going to work on now is actually hooking up the DC motor driver. I've bought one of these RC car speed controllers. As I think I said before, be careful if you're going to buy one. Don't be tempted by the low cost. They do make these things just for airplanes, and they're for propellers, and they only go one direction, so make sure you get the kind that have with stop and reverse, which this one does. And I hooked it up to pin 0 here on the Arduino compatible Teensy, and notice I have actually removed the red wire, the positive wire. The controller itself is going to get its own voltage from a battery pack, and it's got its own power supply and everything. And I really don't want to have to deal with any feedback or misaligned voltages, so if I just pull that out, I don't have to worry about this one having, for example, more power or more voltage than the motherboard does. So we'll just have only signal and ground connected. And of course, I still have this hooked up from, as you saw in the previous videos, it's hooked up to pin 12, 11, 10, I think all the way down to pin 7. And let's take a look at the code. Pretty much, I just basically deleted some stuff and rearranged a few things from previous codes. I still have to include this servo.h, even though there's no servos here. It's because this thing behaves just like a servo. It still takes the same pulse widths of a servo, between 1 and 2 millisecond, with 1.5 being a stop. So I'm going to use the servo.h library. I still have a variable here that's going to save the pulse width that I collect from the receiver and store it so I can use it. I have created a servo object as described by this library, but I've named it DC motor. I can name it anything I want, but I'm going to name it DC motor because this particular servo object is going to control this DC motor. This, by the way, is not out of the Batmobile. It's out of a one of those Jeeps. I think it was a Barbie Jeep that the kids ride around in. It's functionally the same as in the Batmobile. In setup, I'm only going to be looking at channel 0. I don't need to look at all these other ones. So I've actually just rammed out the other channels of the 6-channel receiver. We're just going to keep it simple. So I'm going to look at only channel 0, which is hooked up to pin. Here's channel 0 on the receiver, and it's hooked up to pin 12 on the Teensy Arduino. I have attached my servo object, okay, to pin 0. Right here, very first pin. I'm going to launch some serial so we can look at the stuff that's being sent out. I'm going to jump down here to the loop. Very simple. I'm going to take that variable I created, channel 0. I want to collect, I'm going to take a pulse in. I'm going to measure the size of the pulse, the length of the pulse, on pin 12, which is hooked up to channel 0 of my receiver. I'm looking for a high signal, and I'm going to set a timeout of 21,000 microseconds, or 21 milliseconds. I don't want it to sit there all day long, and this is going to say, well, if you haven't got the leading edge of the pulse in 21 milliseconds, just give up. And then it's going to go to the subroutine drive servos, and it's going to jump up to the drive servos subroutine, and I'm going to take that DC motor servo object that I created, and I'm going to write in microseconds the variable, the value of the variable that was collected down here, and it's going to pulse it. So if all is good, I should be able to load it. Okay, you saw it loaded. Let me hook up some power. Okay, and turn on my transmitter. And I don't remember. Oh, this is off. These things do have a little switch, which is kind of handy. So you can see I've got it hooked up, so it's completely proportional. And it works quite well. Okay. So now it's time to try to get everything hooked up together. I'll get some servos and the DC motor going, and I'll see you shortly.